What's that? You're like animals. Sleep at winter.
Yeah, like me.
Do you know this word in English?
No.
You mean hibernate, yeah.
Hibernate.
It means you sleep in winter. Yes? Alright.
How to spell?
Oh my goodness. I'll try for you.
I'm learning English.
Learning English, yeah. What's it? Help me out here. Hibernate. Is that right?
Hibernate.
Yeah.
Hibernate.
It means sleep
In
in winter.
Like it's too long.
Also, if you look at your computer, there's a button on it called Hibernate, which makes your computer sleep. You know this?
We know Chinese.
Yeah, you know it on your computer. You make the computer sleep.
Every computer.
See? Look. Hibernate. Hibernate. Yeah. Alright. Can you write this down? We'll look at wait.
I'm writing it down.
Did you write it down?
Yes.
Oh, good. Delicious.
The reference that can think is very good.
You like it?
Because at home we just eat reference, eat bread.
That's it.
And sausage. Sometimes sandwich.
That breakfast you have has a name. I wonder if he knows it. Do you know the name of the breakfast they have?
I didn't see it.
No, it's when you have bacon, sausage, hash brown, beans and toast. This breakfast has a name. No,
England breakfast.
no, Irish breakfast. Irish breakfast, yeah.
Traditional
Yes, you are right. You are right. Traditional Irish breakfast. Very good. Yes. So if you go into a restaurant and say traditional Irish breakfast, you get that.
Beans.
Beans too.
Beans,
Hash brown, bacon, pudding, eggs, toast, pudding. Black and white. Yes.
What's black and white?
Black pudding, white pudding.
Ah.
Tradition. Very good. Traditional. Where did you learn that? Where did you learn this? Traditional Irish breakfast. In China. Goodness. All right, you're right. You're right. Okay. Okay. So, definition now. Gravitational force. So if you look here, look. This is not moving. It's at rest. Yes? But if I let go, it moves down. It accelerates down. So there must be a force that's pulling it down. This is called gravitational force. It's the force between all matter, normally only felt when an object is extremely large, like the Earth, Moon, Sun, etc. So the Earth pulls everything to it. The Sun pulls everything to it. Okay, you got that? I think I have more text here. So, gravitational force, you don't have to write this part down, is what keeps you on Earth and not floating in space. So the reason you are here and not flying away is because of this force. Okay, next definition. The weight of an object is how much gravitational force it feels. So the weight is the force that pulls it down. The weight. So for example, which has more weight? This calculator or this table? The table has more weight. Got it? Let's find the formula for weight. Okay, so here we are on Earth, and here is the object, and its mass is m. So there's a force pulling it down, which we call the weight. So the weight is the force, but what's the formula for force? ma. Now we know the m, but what's the a? The g, yeah. So this is equal to mg. So in fact, that's the formula for weight. Weight's equal to mg. As simple as that. And the unit? Newton. And I should point out that we usually make weight a scalar, meaning that we only use positive numbers. So for example, if I say the weight is 10 newtons, I always mean down. 10 newtons down, for example. Okay, you got that? Yep. Newton also, yeah. It's a force. Okay. So this is the formula, as you know. Weight is W, m is mass, and g is the acceleration, which is 9.81. So calculate this for me, please. How much does a 2 kilogram physics book weigh on Earth? So take out your calculators and tell me the weight here. So, what did you get? 18? Try again. 19. 19.62? Did you get that? Huh? Yes, correct. Yes. 19.62 newtons, yeah? Did you get that, Amanda? Yeah, okay. Now, on the moon, the g is smaller. So, on Earth, if you fall, the g is 9.81. But on the moon, if you fall, the g is smaller. It's 6 times smaller. It's much smaller. So my question is, this same physics book, how much weight is it on the moon? No calculator, Sophie? 3.27 newtons. Yeah. Yeah? Did you get 3.27?
No.
Please get it. Yes? Okay. Continue?
Do we add some more?
No. Usually just Earth. Yeah.
What about Mars?
Huh?
What about Sun?
Maybe. We'll see later. A 2 kilogram physics book weighs 4 newtons on an asteroid. You don't need to know what that is. It's not important if you don't. What's its mass? It's still 2, okay? I'm trying to trick you here. The mass never changes. It's always the same everywhere. So it's still 2 kilograms. Asteroid is a big rock in space. And if it hits the planet, it's a problem. You know asteroid?
Yes.
Yeah, you know asteroid. Yeah, okay. Right, so which will hit the ground first?
You just are at the same time.
Ah, yeah, but in real life,
The bowling ball.
Yeah.
the bowling ball will hit the ground first. So, let's just double check that, okay? If you look here, here's the bowling ball, and here's the feather. So, U, V, A, T, S. So, what's the U? We'll say 0. The V, we don't know. A, minus 9.81. And let's just make it easy. Let's say it's 1 meter high. So, the S is...
1.
Are you sure?
Yeah.
No.
Big one.
Yes. All right. Here, what's the U?
Same.
0. V?
Don't know.
Don't know. A?
Negative.
Minus 9.81.
Negative,
Yeah. T and S
Why is 8 minus?
going down.
Brenda is plus.
Ah, but
Minus.
yes, you said it the last time. Always minus. Now look, Amanda, it's fine. If you want to make this plus, that is okay, but you need to make this plus also.
The same.
They need to be the same. Yeah. Correct. Same direction. Okay, so if you were to calculate here, the T's will be the same.
The math is
Say again? The maths?
not.
Yeah, it's, if you did this, you'd think the answer is the same. But if you really did it, the answer is different. This is because this is 9.81, but in fact, this is not 9.81 here. And the reason is, so far, we only considered one force. What's the force pulling it down? What's this force called? Weight. Yeah, weight. But in fact, there are two forces, really. One going up, yeah.
It's not linked.
Yeah,
It's just resistance.
there's another force going up here which tries to slow it down, which we call a drag force. So here the drag force is nearly 0, but here the drag force is quite big. This is what's happening. So here it is in the picture as well. The thrust is what makes it go forward. The drag is what tries to slow it down. This picture would be nice if you could draw it.
Is this a new topic?
It's still kind of part of weight, sort of. No, it's okay. Just draw a beautiful picture, please. Did you draw?
A square and 2 circles.
And did you write trust and drag?
Yeah.
Yes? With the arrows?
Yes.
Good, okay. I can continue? Yes? You didn't draw it yet? Alright. Let's see who has the best car. Show me your car.
One square is 2 circle.
Let's see.
A plus plus.
Look, Sophie has windows on hers.
Little trolley.
Little trolley, yeah. Okay, you got that? No, oh goodness, it's just a car.
A beautiful, nice, wonderful car.
Fast car too.
But,
Yeah.
very expensive car.
Very expensive car, yeah. Okay, continue? Yes? I can continue, yes? Now, what's going to happen is the car will go faster and faster, but it won't go faster and faster forever. It will reach a maximum speed. For example, what's the maximum speed of a small car?
220?
200? No.
160.
160, I think. would be the top speed. 180?
Not sure.
No, maybe 160.
But that's car.
Yeah, but I don't think it can go that fast.
It's going to broken.
Hang on, let me pause the video here for a second.
My
Yes.
sister drove at 180 before. But then I realized that people in Ireland drive very fast.
People in Ireland do drive fast.
Yeah,
Yes.
It's crazy.
Yes, yes, yes.
Yes, look at the bus driver. Turn around.
Yes.
Going down.
Everybody drives fast in Ireland, yes, yeah. Now, what is stopping the car from going faster? Why doesn't the car keep going faster?
Because the drag is equivalent to the thrust.
That's it. As the car goes faster, the drag will get bigger until the drag cancels the thrust. Then it no longer goes faster. Okay? This is called the maximum velocity. This is called the terminal velocity. Terminal velocity is the maximum velocity. However, we usually use this vocabulary when something is falling, usually. So it's the maximum speed when something is falling. It's the maximum speed when something falls.
Different shape have different terminal velocity.
Yeah. The reason something has a different terminal velocity is quite difficult. You know, it could depend on the shape or anything really.
Where do you go?
Do you know M1, the motorway from the airport to Belfast?
Yes.
This motorway.
No CCTV.
Huh?
No CCTV.
No what?
No cameras.
No cameras, no.
Oh, there are a lot of highways in like Malaysian cameras. I mean, there are a lot of cameras in Malaysian
Yeah.
highways.
Yeah. In Ireland, the speed cameras, they're usually turned off.
Oh, why?
I don't know why. Because they break. I don't know. What you need to be careful about in Ireland is a police officer on the road with a camera.
Oh,
This is what will get you in trouble. Yeah. So if you don't see a police officer, like if you can see very far and there's no police officer or there's no car,
Stop.
you'll be okay. Yeah. Do you have speed cameras in China?
Everywhere.
Everywhere.
Yeah.
Everywhere.
There's a news in my hometown.
Yeah.
It's what's that called? Light.
Yeah.
And
Speed camera?
yes.
Yeah.
Maybe 8 speed camera in same. I don't know why. It's
Same street.
No,
Yes.
it's like a same streak of light in
8
different
speed cameras on one street.
No.
no, a streak of light like a car passing by. I
Yes.
think that's what she means.
I will draw a picture.
Draw a picture. I don't know what she's talking about. Do you know what she's talking about?
电线杆很多。
Do you have speed cameras in South Korea?
Maybe.
Many speed cameras?
I think
Maybe it's an Asian thing.
it's normal. Yeah.
It's an Asian thing, you think?
Because you will have accident every day.
Yeah, okay.
Check the words first.
Yeah, there's not too many speed cameras in Ireland. More police officers, you know.
I think especially in the morning, maybe 8 or 9 o'clock is the
This is
problem. And
Problem
maybe,
time.
And yeah, after finish work and go home and have problem.
really okay. There's too much traffic in Ireland for people to drive fast at these times.
But I some from her state, she said in Ireland
Yeah.
they have maybe
Oh,
less
yeah, yeah.
accident happen.
That's what?
Had an accident.
Yeah, there's not,
Hard to say.
there's not many road accidents, road deaths,
Crash,
you know.
yeah.
Maybe I don't know, like maybe about
Oh, the speed cameras are on the electric
Yes!
car.
what is it? What is it?
I got it.
What is it? What is it?
What I wanted to say is that on every light post, there'll be a speed camera on every lamp post.
On every lamppost.
And it's and it's
8
Oh,
cameras,
I see.
cameras
There's
on
one
left.
traffic
Yes.
light,
Yes.
Yeah.
and there's
exactly
8
right. Okay.
cameras on the traffic
Yes.
light.
Yeah.
Wow.
8.
That's amazing.
It's more than 8. I can't remember the.
More than 8.
Yes, it's on today's news, but I.
I won't drive in China, so. Okay. So when we talk about terminal velocity, it's usually when somebody is falling. Okay. We don't need to write that red part down. It's okay. All right. Can I go to the next slide? Right. So let's have a look at an example now. So a car of mass m starts at rest and accelerates with acceleration and a force. We are kind of answered. You don't have to write this one down because we answered it already. Why does the car not accelerate forever? Because when the car goes faster, well, actually, I will write it down. You can write it down. So, as the car goes faster, the drag will increase until the drag equals the thrust. So when that happens, for example, e.g., if this is 1000 newtons and this is 1000 newtons, then the total force is 0. For example. Now, is the car still moving?
Yeah.
Yes, it's still moving, but it's not accelerating. Yes. Sometimes students in the exam make the mistake and they say it's not moving or something like this. No, it's still moving. It's just not accelerating. Okay, can I go down? Yeah. Grace? Well, I just want to say here, I'll write it here. So just to be clear, okay, if this is F1 and this is F2, the total F is F1 minus F2. So you remember Newton's second law is this? Yes? You don't use this one. You don't use this one. You use this one in the formula. The total. Okay? So just be careful with that. Okay, can I go back to the slides? Sorry, Sohi, do you need... It's okay? Alright. Okay, so I have 2 more examples to do. So, a euro coin is dropped from a 100-metre building. How long would it take the coin to hit the ground? If this was really done, would the coin take longer or shorter time than this? Okay, so I'll draw it for you. What you have here is you have a building which is 100 metres, and you have a coin that you drop from the building, and it hits the ground. How long until it hits the ground? So what's the U? It's 0. The V, we don't know. A, minus 9.81. T, we don't know. And S, minus 100. So I'll use S equals UT plus a half AT squared. So here you get T is 4.5 seconds. Now, I want you to think very carefully. If you really did this, would the time be bigger or smaller if you really did it?
Smaller. No, bigger.
No, so think carefully. Yes?
It's going to be bigger.
Is this your final answer?
Final answer.
You sure?
Yeah.
You are right. The time, if you really did it, should be more than this. And what's the reason?
Right.
The drag. Yeah. Okay.
But this is not like important for example. I mean, like
These questions are just to get you to understand the idea. That's all. Yeah. Okay, we'll do a real one now. Okay. So, this is the last example, and this is probably the most important one because the rest were kind of easy questions. So, write this down carefully and I'll do it then. You got this? Yeah? Yes? Can I do that? Okay. So let's just draw what's happening here. So what's happening is you have something like oil. And you put a little ball in the top of the oil, and of course it will start to sink. So it moves down. Now, as it's fallen, what's happening to its speed as it falls? So I think it's worth noting. As it falls, its speed, what happens to its speed? Does it get faster or slower? No, it gets faster. It does get faster. But, well, maybe not, but. Now, if it's going faster, will that make more drag or less drag? More drag. So that means more drag. Or if you want to say drag increases. Okay, so we just need to remember that later. Let's write down the information. What's U equal to? 0. V, do we know V? No. Do we know A? No. Do we know T?
No. 10 seconds.
Thank goodness, I was worried there. 10 seconds. And do we know S?
8 seconds.
Minus 0.8.
Yeah. No,
Okay.
Correct, minus 0.8.
Okay, don't freak me out. Let's find the A. That's what we care about. So what formula should we use? S equals?
I didn't memorize any of them yet.
You should do that now. S equals ut plus a half at squared. S equals a half at squared because the u is 0. So minus 0.8 equals a half a t squared. What the heck? Yeah, no, that's fine. So the A is minus 0.016 meters per second squared. Now think. If there was no oil, what should the A be? If there's no oil? Should be
more.
Should be what number exactly?
Should be higher. I don't know what is it.
1.
Thank you. It should be 9.8.
Yeah.
Because the water.
No, if there was no water, no oil, if you just drop it like this, what's the A? 9.8. This is much smaller because of the drag force. We want to calculate the drag force. So we use Newton's law now, F equals ma.
You mean the acceleration should be negative 9.8?
Yeah, I'm just being lazy with my words. What's the mass? Do we know this mass?
Yeah, 100 grams.
0.1 kilograms, yeah? So that's 0.1 A. So I get F equals 0.16 newtons. Now, if we look at the ball, there's a force going up and there's a force going down. Which force is that?
The force going down is like that's pulling it down is a gravitational.
Yeah, so which force is this then?
Isn't it both?
Kind of both. You're right, this force is the weight, this force is the drag, yes, but this force here is not this, it's not this, it's the difference. So you can say that W minus drag equals 0.16. Actually, I should really have a minus here. You know what? No, it's getting messy. I'm going to drop the minus here. It's getting very messy. Right, that's drag equals mg. Well, it does have minus. So if it has minus, yeah, I don't want to make it seem strange. I should really do it like this, because this is down and this is up. So if you want the minus in Grace, we have to write it like this, which is fine. Okay.
But I thought if it's just force, there's no minus.
No, because force has a direction.
I mean, weight is scalar.
Yeah, but that's just because we never use the minus when we report the weight. But we always understand it's going down. Never up, you know. Drag equals W minus 0.16, which is mg minus 0.16, which is 0.1 times 9.81 minus 0.16. So drag is 0.821 newtons. Now, I have something very important to say when you're ready. Do you have this?
No, I haven't said it yet.
Oh, dude. Alright, well, I'm going to say it anyways, okay? So listen carefully. This drag, remember back here? I said as it falls, the drag increases. So this drag is not constant, it's changing. This is only the average drag. But at the beginning, the drag is 0. During the middle, the drag is 0.821. And at the end, it'll probably be something like 1.642. The point I'm making is this is the average drag. Because we cannot know the drag at every part because it's always changing. We can just know the average. This is the average drag. So, you know, in the middle, it might be this number. But at the start, it'll be 0 because it's not moving. And at the end, it'll be much bigger than this number because it's going fast. So I think it is important to remember that that is just the average drag. Okay. You can write this down. Question? No. What class have we got next?
Next tutorial.
What room?
D213.
Which room?
D203.
Tutorial in D213.
I could be wrong. Maybe check.
302.
Sophie, you got a question?
Oh, really? It's here.
I'm not sure.
Let me check.
Why does F equal MA? Why 0.16?
Where is J?
I'm doing this to get the acceleration. No, sorry. Wait, what? Hang on.
Oh, they
Sorry.
they forgot to
I-
add the. So where
What
is
did I
it?
do? Did I write it wrong? Oh
It's
no.
supposed to be A or B.
Yeah, it will be.
I think we have to check both.
What am I doing? Oh, sorry. Yeah, sorry, Sophie. What I'm doing here. So, are you happy with this calculation? Yeah. Okay. So I know the A. Did I write it the wrong way around? No. Oh, rats. So sorry. Thank you, Sophie. I did this part wrong.
What's wrong?
Well, the A is this. I should put the A here and the M here.
And get the F.
Yeah. Right. Thank you, Sophie. So F equals MA, which is 0.1 times 0.016, which is...
Zero.
0.0016. So look, my answer is too big. This should have been, I'll fix it here, this should have been 0.0016.
But
0000.
minus.
Yeah, there's a minus here. Sorry. Minus 0.0016. Right, so recalculate. Messy. No, I had breakfast as well. So the answer should have been 0.979 newtons. Not this number.
Why is it negative weight plus drag equals that?
Here?
Oh, because it's going down.
Okay. Are they business students outside? I'm not ready for them. Okay, can I go back to the slides? Yes?
Yeah.
Alright. No, stop doing that. It's not, it's only 4 questions. Would you come on? 1, 2, 3, 4.
Look at this English.
Yeah. Oh, so beautiful. Alright. So, wait, hang on. Grace, when's your next physics class?
I don't know.
Monday. So you have lots of time to do the 2 homeworks, okay? Alright, do them.
See you next year.
Yeah. Yeah, actually I won't see you until Monday. Yes. Yeah, so am I. Very happy.